Hello everyone, so let's start with operators in Python. So operators are basically symbols that we use to perform, that are used, that symbolizes, some operations, right? So data science is, a field which has, a part of statistics, mathematics, all these included. So we have to do some calculations, some operations. To perform those operations, we use operators, right? And I don't know if you know what operands or operators are. Let me show you a very, very easy example that we have been doing since I don't know how long, okay? Like 4 plus 5, right? So here 4 and 5 are operands, okay? Let me show you. Let me write it, right? 4 comma 5 operands, and the plus symbol is operator, right? So this is operator, this is operands, okay? So there are like 6 types of operators in Python: arithmetic, assignment, relation, logical, bitwise, and membership. We're going to cover all these 6 in detail in this video. So let's dive right into it. Number 1, we have arithmetic operators. So arithmetic operators are those operators that we've been doing since I don't know how long, like from our very, very childhood, right? Like addition, subtraction, all these easy ones, right? We've been doing it for very, very long. So if I'll show you those, the list now, you'll understand how easy it is. The new concept would only be modulus and floor division that we're going to cover in this only. So it's very, very easy. We know what addition is, we know what subtraction is, we know what multiplication is, we know what division is, right? These 3 you might not know, but we're going to cover this, so we'll get to know. So what modulus does is it gives us the remainder after division. So the remainder after division is the output of modulus operator. Exponent means power, right? Like this here means 12 and its power is 5. So 12 times 5. 12 into 12 into 12 into 12 into 12. So that is the output. This is what double asterisk does. Single asterisk is multiplication, double asterisk is exponent. The symbol is called asterisk. Next is integer division, or we normally call it floor division. So what floor division does is, like on dividing 12 by 5, we get a decimal result, right? So what it does is it removes the decimal part and returns only the integer portion of it. So on dividing this, we got 2.4 something, right? So that it won't give us 2.4, it will give us only 2. The integer portion is only the output. The decimal part is removed on doing the floor division, right? 2 times using this symbol, we get that. So let's do it practically. I'm going to take 2 variables, right? And we're going to give them very, very basic values so that we can also, see if the calculations we're doing is correct or not. So first is, I'm directly going to print all these things, okay? Whilst I'm doing this, I want you to solve this on your own so that you can check it. Okay, so I don't remember how many of these. So we have done multiplication, division, modulus, and floor division. There's one more left, that is exponent. We can also use calculator to recheck it, but before printing the output, let me show you what according to me should be the output. Like 15, okay, 5, 50, 2, 0, because on dividing we get 0 only, right? And here because the division does not include any decimal points, so the division and floor division are going to be the same, that is 2. And exponent is it's going to be 1 2 3 4 5. So let's just print the outputs. What mistake did we do? Oh, we did not run this, that's why. Now it is going to work. See, we got the exact same output, right? These calculations are very easy. I don't think there would be any other problem in these, okay? So if you have any other problem, you just let me know. Integer division I'm going to show you again, and modulus also, right? So let's divide 67 modulus 10. So now you would know. See, it gave us 7 because on dividing it, what did we get? 6.7. So it rounded it off. Oh, I'm sorry, it's not rounding it off. I actually misinterpreted it. It's the remainder, right? Because 60 is what we get and 7 is the remainder. But if we do, wait, I'll leave it here only. Now if I do 67 floor division 10, then we're going to get 6. See, sorry I confused you with that, but that's not the case. It does not round it off or take the nearest integer. No, it takes the integer that is actually there. It just removes the decimal part in floor division. And rest exponent is easy. If you have any other doubt, you just let me know. Next up, we have assignment operator. So what assignment operator does is, it is used to assign values, right? So it can be as basic as assigning like a simple value, or it can be a little complicated, like doing some calculation and then assigning the value, right? So what does this do is, I'm going to show you practically, okay? You just see those. These we're going to do after we've done the bitwise operators, okay? Before that, it is a little difficult to understand. So let's do assignment operators. The most basic assignment operator that we've been using is equal to. A equal to 5. So this is the basic assignment operator, right? Next up, we have plus equal to. So we have done arithmetic operators. We're going to use all these arithmetic operators with assignment operator, right? So I'm going to print A, right? What I've done is I've written A plus equal to 5. Now I'm going to print A again. Let me print this one first, then this. It is going to show us 10. Why? Because it is doing is A plus 5 is equal to A. What this means is A is equal to A plus 5. Got it? That's what it's doing. Every time we use such operator, it is doing the same thing. I'll show you. If I use minus here, it is going to give me what output? 5. Why? Because it was 10 already. Now we've subtracted 5. Now we're going to multiply it. So now the value of A is 5 here. It's 5, right? So 5 into 5 is going to give us 25. Now that we are going to divide 25 divided by 5. Why 25? Because we've changed the value of A. 25 divided by 5 gives us 5. So A is going to be 5. Changes are made in the left hand, are stored in the left hand side operator, okay? Operand, sorry. So we've done like what? Up till here. Now we're going to do these. Now let's do floor division. We have 5. So there's no point of doing, 5. So we're going to floor divided with 2. So what output? 5 divided by 2 is 2.5. So what output we're going to get? 2. See? Now what we're going to do is, let's do exponent. So 2 power 5 is going to be 32. See? Now we'll do modulus. Okay, so modulus is divide by, it is going to give us remainder. So 32 divided by 5 is, what's the remainder? 2, because 30 is divided by 6, so 2. We got it right. To understand these and or XOR, left shift, right shift, we're going to first do the bitwise operators, then we're going to come back and do the assignment with bitwise. Okay, now that we've understood assignment, let's move on to comparison operators. Comparison operator means to compare two or more values, right? So when I started my graduation, I was very much confused with this symbol. I couldn't understand the meaning of it. Now I know what it means. This is to give us whether A is equal to B or not. It is going to, let's see what is it going to, I'm sorry. A is equal to 5, B is equal to 10. Okay, and what we're going to do is, it has given me false. It returns Boolean value. What I did is, I asked it that whether A is equal to B or not. Why did I not use only single equal to? Because that means assignment in Python or in any coding. To check whether two variables have equal values, we use double equal to in Python. Okay, that is number 1. Then we have not equal to. I'm going to copy this and I'm going to use this only. Actually, I don't need to change the values, right? I'm just going to use the, see, A is not equal to B, right? Because it is 5, it is 10, so it is true. Is A smaller than B? Yeah, it's true. Is A bigger than B? No, it's not true. It's false, because A is 5, B is 10. Okay, we've done these 4, less than equal. Now, next is less than or equal to, greater than or equal to. These are also very similar. It checks for both the conditions, right? So it is less than, so it is going to say true. And it is not greater than or not equal to B, so it is going to give us false. This is comparison operator. It is very, very easy, and we've done this like so many times in school, and I know everybody of you must know this, must have used, not specifically these in this way, but in some way or the other we've used this, like whilst comparing the prices on Flipkart and Amazon before buying something, right? These are the basic things that we do. When we do it mathematically, it might seem a little complicated, but it is very, very easy. It is related to our real life, day-to-day life. Next up, we have logical operators. So, logical operator, before understanding what is logical operator, let's just go through it. This is something that is related to this truth table. Okay, but we are not going to do this with truth table. We are going to do this using conditions, right? In the next video, we're going to do control flow statements. So there we're going to read like if else statements, right? But right now, let's just take it easy. Let's say I'm making a condition. If A is less than 18 and A is not equal to female, okay, print not allowed. Okay, so here what I've used and. Okay, you don't have to understand the A, if the syntax, the indentation, nothing, just and. So let's understand and. So and means, sorry, I've written or here. And means both the condition should be true. Whatever the conditions are mentioned on the left hand side and the right hand side, both should true, both should be satisfied. That means and. Okay, if we write or means either one of the conditions must be true. Like if only this is true and this is not, it is okay, it is going to work. If both are okay, that is also fine, right? To understand this concept better, let's just go through this table once. This is OR, this is AND, this is XOR. So if both are not true, okay, both are false, then in condition OR it is going to return us false. 0 here means false, 1 here means true. And in AND also it is going to return 0. XOR also. XOR we haven't done yet. We are doing logical operators, and those include AND, OR, and NOT. So let's just look at AND and OR. So OR is going to be false if both the conditions are false. Okay, rest in any condition, like only if one is true or both are true, it is going to return true. And the AND has extremely contradictory, complementing, contradictory, we can say contradicting conditions. Here, if both are true, then only it is going to be true. Otherwise, it is going to be false in every condition. See here, A and B are the conditions. Okay, let's assume A and B are the condition. So if A is false and B is false, then on using the condition OR, it is going to return false. That's how you read it. Okay, 0 is false, 1 is true. Understood? That is what it means. And in NOT, we only have one conditions. Okay, this is easy. When we are going to use it in the real programs, right? Using the control flow statements and all these things, functions and control flow statements, when we're going to do that, and when we're going to practice these questions like with some examples, then we're going to understand this in even more better way, right? Right now you just know this truth table that I showed you. This is the truth table, okay, for OR and AND, how to write it, like simply OR and AND. This is very easy. We're going to understand it very, very nicely. Right now you just have to understand this. Even if you have doubt, it is okay. When we cover those topics, it is going to be all very, very clear, crystal clear. If you have even iota of doubt, no, it's going to get clear as we move forward. You don't have to worry. Okay, so now that we have done this, let's just move on to bitwise operator. It is very, very fun to understand. You might not know the basic binary calculations and everything, but I'm going to show you as we do the basics of binary calculations also, and how the bits works and everything. And with respect to these 6 operations we're going to do. Okay, so we're not going to do first on Jupyter Notebook. We're going to see on the workbook only, using layman's term and pen paper style. Then we're going to do it hands-on in Python. Okay, so let's just understand it in the layman's term using the notebook. Okay, so let's just take let me just tell you, in binary, 0 is 0, 1 is 1. I'll just show you how the numbers are written. Okay, that way you're going to understand the pattern. That's how I understood 1, 1, 0, 1, 1, 1, 0, 0. Okay, let me just give you a couple of more examples to understand this in a little more better way. 5, 6, and 7. Okay. So this is going to be 101. This is going to be 111, 110. Sorry. This is going to be 1, 1, and 1. Right? Next up, 8 we're going to write is like 1000. And the same pattern will go on. This is how we write numbers. Okay. So the first operation that we're going to see is tilde or not. This is complement. Okay. So let's take the number 4. It is written as 100, right? That color won't be visible. So 100. 100 is 4. To find the not, what we do is we simply change it. if it is 0, it is going to be 1, and if it is 1, it is going to be 0. Okay, so let's just change it. It's 0, so it is going to be 1. It's 0, so 1. 1, so 0. Okay, so let's just quickly see how to change binary to decimal. Let's just do that. To change binary to decimal, we have to do very simple calculation, that is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. Now what we have to do is we have to multiply this with this, this with this, this with this, and then we have to add these. Okay, so 1 into 4 plus 1 into 0 plus 2 into 0 plus 1 into 0. So anything multiplied by 0 is 0. So what we get is 4. So 100 is 4. Here let's see what we get. 2 raised to power 0, 2 raised to power 1. We already know that what this is, right? This is 3. Let's just quickly see. You'd be surprised to see what the output Jupyter Notebook shows. Okay, so this is going to be 1 plus 2 plus this is going to be 0, so we're not adding, so it is 3. Okay, before I move ahead, I just need to make one correction. We use 8 bits. Okay, so let's just do 8 bits thing. So this is 8 bits. 8 bits means there should be 8 digits. So here are 8 digits. So this is going to be 4 only, but on doing the calculation, this is going to be 251. I made that mistake because I forgot the bits concept, but that's how the bits concept works. There are 8 bits. Depending on your system, the bit system works. So we're taking the 8-bit system. So this is going to be 251 on doing this 2 raised to power calculation. Okay, but you'll see what output we get. Okay, let's just do it on the Jupyter Notebook. This is the operation we're doing. So we get -5. Let me tell you how this output that we got is correct. Okay, so -5. Okay, firstly we should know that the system, to write negative values in the system, what we do is we use 2's complement to store negative values. Okay, let's find 2's complement of 5. So 5 is, here we can see it is 101, right? So let's write 101. 101. So for 2's complement, what we have to do is we have to first find the simple complement. The simple complement is 0, 1, 0. Again, I made the same mistake. Let's just quickly do it. 8 bits. It's 4 to 6, 7 and 8. Okay, and I'm going to write the complement quickly. This is 1's complement. Now for 2's complement, what we do is we add 1. So 1, 1, 1, 1, 1, 0, 1, 1. So this is how we write -5 in bits. Okay, and the output we got is the same. So it is also 251, and this also represent -5. Usually the system does not store values in negative form, but to represent negative form, what we do is we take the number and we find 2's complement to denote its negative. So that's how it's correct. Okay, I hope we got it right. Okay, moving on to the next operation, that is AND. Okay, before moving on to AND, let's just quickly look at the table. Let's just do OR first. Okay, so we have to remember while doing the calculation, if it's 0 and 0, both the numbers are 0, we're going to write 0. I'll make this table quickly over here. Okay, OR truth table. 0, 0 is 0, 0 1 is 1, 1 0 is 1, 1 1 is 1. Okay, let's see, we have 4 or 5. Okay, and OR is represented by this is the symbol that's right above your enter key. Okay, so 4 we write is 100, 5 we write is 101. Okay, so 0 and 1. 0 and 1 is, seeing the table here, let's say 0 and 1 is 1. 0 and 0 is 0. 1 and 1 is 1. So it should return what? 5. Okay, let's just see if we are correct. What we have to do is we simply have to see we're correct. We simply have to look for the truth table and do the calculations accordingly. Now we're going to make the truth table for AND. Okay, so 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. So it is only true if both the conditions are true in AND function. This is like for AND. AND is represented by this ampersand. Okay, let's take the same 4 and 5. Let's see what we get. 100 and 101. So 0 1 is 0. 0 0 is 1 1 is 1. So we're going to get 4. Let's just check it on Jupyter notebook. Okay, 4 and 5. We got 4. See, we're correct. So we've done this 3. Okay, let's just see XOR. So in XOR, to understand XOR, let's just make the table XOR table. Okay, I forgot the symbol, so I was just checking it. Symbol for this is this one. Okay, here if both are same, it is going to be 0. If both are different, it is going to be 1. That's how we remember it. Okay, let's do it for same 4 and 5 XOR in XOR operation. So 1 0 1, it is different, so it is 1. It is same, so it is 0 and 0. So what is it going to return us? It's going to return us 1. Let's just see for ourselves, right? See, we got 1. We're correct, right? All that is important in these 3 operations AND, OR and XOR is the truth table. And this is very, very easy. In XOR, if both are same, it is going to be 0. If both are different, it is going to be 1. In AND, if it is 1 and 1, then only it is going to be 1. If both are true, then only it is going to be 1. Otherwise, it's going to be false. And it's going to be in OR. It is going to be false if both are 0. Otherwise, everything is true. Okay, so we have done like 4 operations in bitwise. Only 2 left are left shift and right shift. Okay, so let's just move on to those. Left shift. So let's take the number 100. Like I can write the number 5 as 5.00, right? In the same way, in bits also we can write 100.000, like as many zeros as you want, right? So that's how we do it. In left shift means we move 2 bits towards the left. Okay, so let's move 2 bits towards the left. So that is going to be, these 2 bits are going to come here. Okay, so 0 0, we already have hundreds ka 20. So this is what we're going to get. On left shifting, what we did is we moved this to the right, and we brought these 2 to the left hand side. Okay, And so let's just see what are we going to get by using the simple binary to decimal conversion technique. Okay, so all this is going to be multiplied by 0, so there's no point of calculating it. This 2 raised to power 4 is going to be 16, I guess. Okay, let's just see. 2 into 2 is 4, 4 into 4 is 16. Yeah, so it's going to be 16. So let's just see the left shift of 100. Okay, left shift of 4. 100 is 4, right? Just a second. Okay, so let's just start with the left shift of 4. So how we're going to write this? The left shift symbol is this one. We're going to write 2 because we're moving by 2 bits. Okay, that's what we did, right? Let's see the output. It's 16 and it matches with our output here. See, we got 16 over here. That's how we do left shift. I know now right shift is also very much predictable, but let's just check it. So right shift of 100 only. Okay, so what we're going to do is we're going to move 2 bits. Okay, here these 2 bits are going to move behind the decimal. Okay, so what it is going to return is 1.0000 and 0 according to this. Okay, so on doing the right shift of 100 by 2 bits we get 1. Okay, let's just check it on our Jupyter notebook. 4 right shift 2, we get 1. Understood? This is how we do it. All this bits conversion is going to be a little new for you, but it is all very easy. Once you practice it like a couple of times, it is going to be a piece of cake. Okay, so now that we have done bitwise operators, I want to tell you that this is the operator that I've been scared for so long. I've done C, I've done C++, I've done Java, many languages I've tried, and the only thing I've left in all those languages is bitwise operators. But when I did Python, I was like, I need to do this correctly, so I did it, and I now can say that I know bitwise operators with you can just wake me up in the middle of the night and ask me what bitwise operators are, and I am fully capable of telling you what this is. So this may be a little bit haunting, or a little bit something that you can be terrified of right now, but as you practice, it is going to be the easiest thing you've ever done. Okay, so the next is membership. This is very easy. Okay, very easy to understand also. Membership operators tells whether we have been using like a sequence to store a sequence or a collection of data. We have been using lists, tuples and everything. So if we have to find that whether a value exists in that sequence data, then we use membership operator. Okay, so let's just see it. Okay, so let's create a list. Okay, I'm simply writing random integers. Then we're going to see. So let's just say, is 78 in list 2? It returned false. Why? Because we did not have 78. Okay, let's just check for a number that is present. Okay, is 3 in list 2? True. See, because 3 is there, 78 was not. Let's see for not in. Is 67 not in list 2? We don't have 67, so it is true. Is 56 not in list 2? False, because we have 56. this is like the easiest thing to understand. Okay, that is membership operator. We're going to use it when we have to find if an element is present in a sequence of data or not, right? So with that, we have done operators in Python. This is very, very easy, fun concept. You just go through this, practice it, just don't watch the video, also do some calculation by your own. Then you'll see this is the easiest thing you've ever done. Thank you for watching. See you soon.